told Madeline, but it was hilarious.
Isn't that great? It's funny when you can get away with stuff like that every once in a while. You know? So let's talk about some how we actually are going to utilize these. Let's talk about how we're going to actually utilize, gentlemen. Let's talk about how we're actually going to utilize this information of how we work with ratios and proportions within what are called similar polygons. Now, obviously today we're short periods. I think we're out of here at what, about 20 minutes or so. We'll probably be able to get through about the first half of this, which is fine. Being able to get through the idea of what shows that things are similar and how you write out what's called a similarity statement is the most important thing that we're going to do over the course of the next week. Because if you can get through this, everything else is cakewalk. I mean, it's so unbelievably straightforward. There's no craziness involved to it. It's just a matter of understanding what piece goes with what. It's very, I hate to use this word, it's very similar to what we did with congruency statements. When we first talked about congruency statements, if we had two figures that were congruent, all of the corresponding parts were congruent, whether they were angles or sides or anything like that. Well, it's almost the exact same thing with similarity, but there's going to be ratios involved, okay? So what we do here is we have polygons are similar, and this is the main idea here. Polygons are similar. This goes for triangles, rectangles, whatever. Any polygon, if all of their corresponding angles are congruent and the sides have common ratios. That means all of the sides, the way that they line up, are proportional, which means every fraction has to equal each other. Okay? Now, it is very important when we look at it, first example, is how you label. Okay? So they're going to be similar if the corresponding angles are congruent and the side lengths are proportional. And what I'd like you guys to try and do is try to draw let me pull that up a little bit. Try to draw these two polygons here, these quadrilaterals. And I'm going to walk you through how you write out what's called a similarity statement so that way you can show that the angles are congruent and we can tell whether or not the sides are proportional. Because that's kind of what we're going to do today, and that's about all we're going to do, is to determine whether or not something is similar. Now, they don't have to be absolutely perfect. Close-ish is fine. Oh, I got a funny story. Never seen stories. A couple days ago, a package came to the house from Fanatics, and you know where they order all the World Series stuff and all the Cubs stuff. So my wife saw it. She's like, "Oh!" So she opened it up right away and takes out this really nice sweatshirt and then some other stuff. She's like, "Oh my God, was I not supposed to open this? Was this for Christmas?" I'm like, "Well, I didn't order it. It was 813 next street over." No, I retaped the whole thing up, put a big note on there, and I said, "Go Cubs." You have good taste. My wife thought I bought it for her.
She probably got so hyped.
So now I kind of have to go online and find something similar.
Was it a jacket or a sweatshirt?
It was a sweatshirt, one of those really nice sweatshirts.
See, I'm waiting to get stuff from Sam because she gets so much.
Yeah.
She gets so much stuff.
Did you get a share?
I don't know. I'm trying to find that out. I know she's good. I think she does though, and she gets the ring. Yeah, we should have like a. We should get a.
She gets a ring.
Sure. Oh my God.
Wait till you see my day of my 45 day.
Oh, I know, right?
You'll love my day. All right, so here we go.
We're doing it in the spring.
Yeah.
Precious those rings are.
So here's what we do. What I want to do here is normally when I set up similarity statements, I work from left to right. That's how I read. You can work right to left. It's not a big deal. It's just a matter of as long as you're consistent, you're going to be fine. Bless you. So what I want you to do is pick an angle and start to label. So I'm going to start with D, E, F, G. So D, E, F, G. And I'm going to see whether or not the other figure has the same tick marks. Okay? J has 3, K has 2,
Do they have the same angles?
L,
In the same order.
and then M. Yep. We want to keep them in the same order because that's following the tick marks,
Yeah.
just like we did with triangles.
Yeah, I
Okay?
know, but they're not similar.
We don't. Are the angles congruent though?
Yeah.
That's
Okay,
fine.
it's the
That's the first step.
It's the first
You
step.
label out with the angles.
Angles
Now-
have to be congruent.
What we're checking here is to see whether or not something is similar. What the symbol that we use for similarity is squiggly. Okay? We're checking to see, is this true? So now what we do is we listed out our angles. Now we have to write out the corresponding side lengths. So remember how we did this before? Side length DE has to correspond to JK. So I do this. Is DE over JK the same as, see how I'm just going right through the letters? EF to KL, FG to LM, and then GD to MJ. All I'm doing is writing out the 4 side lengths in order that they appear the same way that you would with your angles. We've done this 100 times with triangles. All I did here is add a side. That's it. What I need to do now is check to see if all of those ratios are equal. I need to see if each one of those fractions simplify to be the exact same value. If so, figures are similar. That's it. So what was the value of DE? 15. Let me move this. Actually, let's do this. So 15 over 20, is that the same as 6 over 8? Is that the same as 12 over 16? And then is that the same as 9 over 12? Whiskey. Stop. Take it. Now all I have to do is take your calculator out and see if each one of those simplify to the same value. Right.
They all reduce to 3/4.
What's 15 over 20 simplified to? 3/4. What's 6 over 8? What's not 12 over 16? Are they all the same?
Yes.
Therefore, they are similar. If all 3 of those, all of these ratios simplify to be the exact same thing, which they do, they all have, that's then called a scale factor of 3/4. The sides, since all of their sides simplify out to be the exact same fraction, that fraction is called a scale factor.
So you guys, it's like that, if we had that polygon, a picture of the polygon on your cell phone, because you probably have lots of polygon pictures on your cell phone.
No.
And then you did the, the double tap. Remember I told you on Tuesday, you do this, right? Is that what you do? Okay, you do that, you make it bigger, right? So that would be an what? So you do?
It's true, I'm
Okay,
with
you
you, I'm
do
with
that,
you. Yep,
right?
yep,
Okay.
that's all it is.
There you go.
That's all we're looking at today, guys. Can you, guys? All I want you to be able to do right now is be able to write out the angles in order, write out the segments in order, and check to see if the fractions work. That's it. What we can do from that later on is that eventually we'll be able to take that scale factor and find the missing side length. Remember how yesterday you had that basket problem where we had to find that missing width? Well, they gave you the 2 different ratios and stuff to figure out. What we're going to be able to do is just be given a scale factor and work out of there. Okay? So there's going to be a little bit, it's just adding a step to what we've been working on.
So
Okay?
are they ever gonna give us that 3 over 4 thing? And make us-
Like a scale factor?
And figure out some side lengths?
Just
Not really, but what'll happen is that you might be given, you might be told that something's similar, and you might not know some of those values, but you can figure that out because if you know the scale factor, or if you know one set of the sides, you can reuse this to find the different parts there. And that's the idea. Okay? They give you guys a couple of these to try out here.
She ride Rona's shotguns.
I was gonna say, yeah, your music's still on. Because I saw you guys going.
That sucks. Huh? Cause I couldn't get him. That'd be nice though. He's old though. He is? I thought he was like 30.
His first year was 2,000 Alice.
Oh, damn. We need him.
Oh, we took the outfield.
We need to get rid of him. Nah. Yeah, shit.
We have too much money in here.
That's it, just two of them.
He's only.
What I have here for you guys, two problems. You'll have two different sets of polygons. You have to write out the similarity statement, which means pick an angle, walk through the angles. Go through the side lengths to check to see if all the ratios simplify out. And if it does, the scale factor is the simplified fraction. It's the exact same thing of what we did in class, just two different pictures. All right? Because then we can build out of that tomorrow to, like you were asking, how we'll find a missing side length. And that's kind of where we get to. Because if things have the same scale, if two figures are similar, all the corresponding parts are then similar. And it's easy to work with.
12/8 grade. Today's the 8th grade.
There you go, guys. I put them on the board for you. That way you can see them. There you go.
What page was it again? Page.